In this demo, we will look at how to declare variables and assign values to them. We start off by declaring a variable LNum of type number. Since we have not assigned it a value, it is null at this point of time. We define LNum constant, which is a constant, and as constants, they have to be assigned value at declaration, which cannot be changed later on. We assign it a value of 5. LNum default is defined as a fixed point number with a precision of 5 and a scale of 2 and assigned a default value of 5.2. LNum float is defined as a floating point number with an initial value of null. Later, in the execution section, we assign it a value of 3.245. Then we have a few dbms output.putLine statements printing the values of these variables. Let us run this block. As expected, LNum is null. LNum constant has a value of 5. LNum default has a value of 5.2. And LNum float, which is a floating point number, retains the decimal digits in 3.245. Let us take a look at how scale comes into play when we define a number as a fixed point number. Here, we have defined LNum as a fixed point number with a precision of 5 and a scale of 2. So the total number of digits cannot exceed 5 with a maximum of 2 numbers after the decimal point. It is assigned an initial value of 123.45 and later the value is overridden to be 123.789. We have a couple of dbms output.putLine statements to print the value before and after. Let us run this block. As expected, from the dbms output, we observe that LNum retains its initially assigned value of 123.45 as it satisfies the precision and scale requirements of 5 and 2. In the second case, 123.789 is rounded to 123.79 as only 2 digits after the decimal point are allowed due to a scale of 2. What happens if we assign LNum a value of 1234.56? This would raise an error as 0.56 would be retained to satisfy a scale of 2 and 1234 before the decimal would make the total digits to be 6 and we are allowing a precision of 5. Let us run this block to confirm this. As expected, we see that there is an error which is being raised for number precision being too large. What if we define the scale as a negative number? In that case, Oracle rounds the actual value to the specified number of places to the left of the decimal point. Here, we define LNum as a number with a precision of 5 and a scale of -2 and assign it an initial value of 12345.678. Later, we override the value to be 156.456. Let us run this block. As from the dbms output.putlines in the console, we notice that 12345.678 gets rounded to 12300, so rounded to 2 places to the left of decimal point. Similarly, 156.456 gets rounded to 200.